Hi and welcome to Geeks for Geeks. Today we would be discussing yesterday's problem of the day, that is largest sum cycle. So without any further ado, I would give you, let just present the screen. Yep, it's done. Okay. So my screen is visible. Let me just change the layout to this and it's done. Okay. So now let me just copy paste the question. So in this question you are given a graph. Okay, in this question you are given a graph where cycle are present. Okay, where the cycle are present. Now in this graph, suppose this is 1, this is 2, this is 3, and then this again, and then 4, and then 5, and then 6. Suppose this kind of graph is given, but here it is told that this would be a directed graph. Okay, this would be a directed graph. So basically we are given a graph where cycle might be present. We need to detect the cycle and we need to return the maximum sum cycle. Okay, what do we mean by cycle in a graph? Cycle in a graph means that there exists a path where the starting and the ending position are same. So basically if we start from this point, then we would go up. Okay, sorry. If we start from this point, like we can start from this point also. If we start from this point, we would start from here, we would start from here, we would go till here, and we would go till here, and we would end at this position. So we are ending at the same position. So a cycle is present. So basically, in this question, we need to return the maximum sum cycle. Now, how would we find the sum in a path? So basically, it is just like a game. Like whatever we visit, we just pick it up. So it is just like this. Suppose I'm walking down the road. Okay, I found a 10 rupee note. Okay, like suppose I'm walking down a road like this. I found a 10 rupee note. I found a 20 rupee note. I found a 30 rupee note. I would pick all of them, and the amount of money earned while walking from this to this is 10 plus 20, 30, that is 60 altogether. So in the same manner, if we are traveling from this part, that is 1, so the profit is 1, 1 plus 3, 4, 4 plus 2, 6, and then it ends. Okay, because we have already encountered n. So in total, we have a value of 6. So let's suppose this is a cycle. So 4 plus 6. Now we have the next cycle as 4 plus 6, 10, 10 plus 5, 15. So this cycle has a value of 15. This cycle has a value of 6. So basically, this is the correct answer. Okay. So this is given. So here, let us see the first sample test case. Uh, Hi, Joel. Good evening. Hi, Rishid. Hi, Ruth. Okay, so let us first solve this test case. How it is coming 3. So it is told that the nodes are 0 index. Okay, this just means that this is mapped with 0, this is mapped with 1, this is mapped with 2, this is mapped with 3. So now we have an edge from 0 till the value of 1, then 1 till the value of 2, and 2 till the value of 0. Okay, and the value 3 does not have a path to anyone else. Okay, so as you can see that this is a cycle. Okay, so basically 1 plus 2 is equals to 3 plus 0 is equals to 3. That is why there is only one cycle and the sum of that is 3. Now let us see if any more test cases are present or not. Yes, one more test case are present. So let us see that also. So we have a path from 0 to 2, and then 1 till the value of 0, and then we don't have an edge from 2 to somewhere else, then 3 to 2. Okay, so as you can see that no cycle is formed. So if no cycle is formed, this just means that we don't have any sum. If we don't have any sum, then the return value of this is -1 itself. Okay, so now whenever we talk about cycle, there is a fact. The fact is that, so basically what we need to do is we need to detect the cycle, and then we need to find the sum of it, and then we need to return the maximum sum itself. Basically we need to do. So now it might be a scenario that we are detecting the cycle again and again. There might exist many cycles. Okay, might exist many cycle. There might, in the first scenario we come across this, that suppose this is a part of a cycle. So basically basically we can say that this is also a part of a cycle, and this is also a cycle. So two cycle are present using the same nodes. It might be a present that there is a cluster of cycles, and then we are visiting the same thing again and again. So time complexity would be absolutely high, because this cycle would also say that this node belongs to this cycle, this node also belongs to this cycle, but that won't happen. Why? Because we would use a fact that a single edge can belong to at most one cycle. A single edge can belong to at most one cycle. This is what is given. Okay, so we would use this fact. So now if a single edge can belong to at most one cycle, then we can find, then what we can do is we can start from this point, then we would start the DFS. Okay, if we are hitting the same point again, we would go and traverse and find the sum. Then again we would find a node, we would traverse from the DFS. This we won't traverse in this direction. Why? Because when we have traveled in a particular edge, we would mark it. Okay. So now whenever, see, at most an edge can contribute to one cycle. Okay. So we would start traveling the graph. Okay. But if, so we would start from the edge. Okay. Like let me just show you this also. Suppose we have one, we have two, we have three, and then we have four, then we have five, and then we have six. Suppose this kind of figure is given. So we would start from one. So we would visit one. Okay, so we would visit one. Then we would visit two. Then we would visit three. And again, we are visiting one. So when we are visiting the same node again, this just means there is a cycle. So now we would use a loop while the same one is not received. Okay, so we would move forward to one, then we would move forward with two, then we would move forward to again one. So we would traverse the whole cycle. Suppose this is someone, and someone is suppose six. This value is definitely six. Now we have already visited it, and we know that these all edges we don't need to visit again. Why? Because an edge can contribute to at most one cycle. Now we would go to this edge and we would visit it. Then we would visit four. Then three is already visited, so we won't move in that direction. So the only remaining direction is either 5 or 6. Let's suppose we have visited 6. Then we would visit 5. Again, we are visiting 4. This time, we are seeing that we are visiting the same node again. Now we would start a DFS. We would start a while loop. We would traverse the whole cycle. We would mark each of them as visited. So as you can see, every edge we are visiting twice. First with the DFS, And then again, when we are hitting the same node again, we are again traversing. Like, I started off, I came back to the same location. Okay, suppose this is the path. Okay, suppose this is 10 rupees, this is 20 rupees, this is 30 rupees. Let's take the same example. I start from here, I go from here. I found out that I'm getting clashed at the same point. So if I'm getting clashed at the same point, what I would do is, I know that this is a cycle. Now I need the amount of money I would get if I travel in this cycle. So again I would travel. Again I would travel in this, and 10 plus 20, 30, 30 plus 30, 60. Now we know that with the second traversal we would encounter a profit of 30. So basically the time complexity would be big O of 2n, but as the constants are ignored, so the time complexity would be big O of n. So now the idea is very simple. We would make a graph like this, and then we would simply do a TFS. Am I clear with this approach or not? May I move forward to the implementation? Can I have a quick yes or no? Can I have a quick yes or no that this thing is clear or not? Just give me a quick yes or no. Hi, BB Nandan. How are you? Okay, thanks a lot, Astha. Let me just share the tab itself, and it's done. Let me just see. Okay. So now we would have a vector of int when v, and the size can be at maxless 10 to the power 5. So we would simply have a const int n is equals to 1e5 plus 5. Just take 5 more. Okay. And then what we need to do is, we need to have vector of int of visited array of size n. Okay. And then parent. So vector visited, parent, and PNP. We can declare the size at this point. Okay. So we come here. I'm a very lazy person. I would have n, and I would have this as a itself. Okay. So now it's done. So now we would say long answer is equals to -1. We don't have a cycle initially. Now we would say visited dot resize with size and okay. Let's take the same thing because 0 to n minus 1, so that would solve the same purpose. Okay, now let's just have this, and then we have the parent array. Okay, this is done. Now we would start the visiting. For int I is equals to 0, I is less than n, and I plus plus. Mhm. Yes. So visitor, this was, so let's make it G. Yeah. Graph G of I. Okay. G of I dot push back A of I. And this is done. Okay. Now, what if it is -1? So if a of I is not equal to minus 1. That means it is told that this is the given parent. Like minus 1 means that there is no part. Okay, fair enough. Now we would go here. So for int I is equals to 0, I is less than n. Okay, and then we would call the DFS. Now let us design the DFS function at this point. Okay, so now the DFS function would return a long because this answer is a long. This just means that the sum can be large enough. Okay, so now we would have DFS. Okay, so now we would have this node, and then we would have int p with the default value. Like if no value is being passed, then p would be equal to minus 1. Like p would be assumed with minus 1. Okay, then we would say visited of this node is equals to true. Okay, then parent of this node is equals to parent whatever is decided at this point. Okay, so now we would also insert this node pmp dot push back this particular node. Okay, like we would keep pushing it. Then we would visit the neighbors of it. Okay, while neighbors of g of this node, while the neighbors of this node, if it is not visited, if visited of this neighbor is equals to 0. Okay, then we would first find the value from its neighbors. Okay, so DFS of neighbor with the parent as this current node. Okay, so now if z is not equal to minus 1, z would return minus 1 if there is a cycle. So if z is not equal to minus 1, okay, return the value. Okay, else if it is already visited. Okay, suppose we started from this point, we mark that yes, this mode is visited. We come back again to that point. So visited of I is equal to 1. Suppose we have already visited and we are again hitting the same point. That means the cycle is present. So we would say long sum is equals to the current. So this would be ng, the current neighbor. Okay, the current neighbor, and we would say while the current node is not equal to the current neighbor, like till we reach the same point. This is just like this. Okay, we have reached this point. Now again we would visit it to see how many costs we have encountered. Okay, okay, sum plus equals to the value of node itself, and then we would say node is equals to parent of this node. Okay, like we would just keep moving upward. Okay, after all this, if node is equals to neighbor, like we have hit the starting point, then we would return the sum, else we would return minus 1, that a cycle does not exist. If all of this is not true, then return minus 1. Now let me just check. Visited of this node is equals to true, then ng. And then we are visiting the neighbors. If it is not visited, we would visit it neighbors. If it doesn't brings a cycle, minus 1 is equals to cycle. If a cycle is not brought from its neighbor, then we would return the value. Okay. And if it is already visited and we are now hitting the same visited point, then that means cycle is visited. Okay, like we are seeing the same value again. That means we have seen that value earlier. Okay, the sum of this would be equal to ng, and while sum is not equal to ng, we are just visiting it again and again. Okay, now we need to start calling it. Okay, so now we would say if it is not visited of I is not done. Like one edge can only contribute to one cycle only. Then if it is not visited, then answer is equals to max of answer. comma dfs of this particular I itself. Okay, and then auto e dash, okay, auto e dash tmp, like all the nodes that we have already visited, we would say auto of e is equals to where this is visited, and then we would just run it. And then we would return the answer at this point. Now let me just see how many errors am I making. Okay, declared it as a global thing, and now this should work. Yes, this is working. Okay, so basically it might be a scenario that we are there are many test cases, so this is not working. So g of vector of int, okay, like there can be many test cases, so internally we are not able to fix this. Okay, like the graph is very large, it is becoming very large, we are just taking the upper bound each time, no? So let me just clear this, and this when we would come down at this point. Okay, when we would come down at this point, we would say g is equals to, okay, g is equals to vector of int of size n. Okay, this is done. Then we would say visited of vector is equals to this. Okay, and then we would say while a of I, edge of I is not equal to -1, we would say v of I dot a of I, and then we would say if it is not visited, then we would just to visit it, then we would visit the neighbors of it, we would clear it at the end, we would just return this. Okay, this is done. Now visited of this neighbors is equals to true. Long p is not equal to -1. Okay, and then if it is not visited, we would visit the neighbor of it if it does not return. So okay, we are not handling the condition, we would return this value. So long z, yes, this is long, while node is not equal to and sum plus node, return the sum, else return -1. Let's and see again. What is the error? What will happen if we have the largest sum which are already part of, no, so basically it won't happen. Why? Because a single edge, okay, it won't happen. Like, let me just show you. So it won't happen because a single edge can be a part of only one cycle. So basically this is dependent on this thing only. Okay, this won't change. A single node can be a part of only one node only. Okay, anything else? How did we arrive at the constraint that only? So basically this is a fact, that can't be denied. This is a fact that can't be denied. Okay, like this is already, this is like we can't really change this thing. Okay, anything else? Okay, so I think this is done. Any more further questions you have? Quickly ask me. Quickly ask me if there are any further questions. I would wait for the next 30 seconds, then I would turn off the session. Okay, I hope this is clear. So now, okay, if we have contributed for that contributes to one cycle only. So basically, the intuition is like, let me just share the screen. Basically, the intuition is that suppose there is two cycle. So now this thing, like this cycle, okay, like let me just show you this. Okay, let me just stop presenting the screen and let me just show you the entire screen. Yep. See, so basically, if we have one, then two, then three, then let's suppose four, and then let's suppose five, and then let's suppose this. So this won't happen. So four, and then seven, and then eight. Okay. So this thing won't happen. Why this thing won't happen? Because if the path is a directed path, then suppose this is a cycle, this is a cycle, this is a cycle, this is a cycle, this is a cycle. So basically this is a cycle. Okay. But let's suppose if we have this cycle in a directed graph, then this thing won't ever happen. Okay. Like see, if we have this, if we have this, if we have this. So basically, we have two incoming edge to a 4. Okay, like two entry points to a 4 and two exit points. 5 has two exit points. It has 2 also, it has 8 also. Okay, 5 is having two exit points. See, the outgoing edge of 5 is this one. The outgoing edge of 5 is this one, which is 1, and the outgoing edge of 5 is this one, which is 2. But here it is written in this question, see. Mhm. Yes, see. The task is to find, yes, see, this is the point. Yes, see. The task can have multiple entry points, but not more than, let me just make it to one line. Yes, see, not more than one exit. Each node can have multiple in degree. Okay, like the degree in degree of a particular node can be more than one, but the out degree of a particular node can't be more than one. Okay, this is written. So this contradicts this. Like this 5 node has out degree of 2, which is not true. So either this condition would be true and that condition would be false. So if it is given in the question, then this condition would be false. This condition would ever happen. So now am I clear with the intuition, like how this would happen? Rishit, am I clear with the intuition, like how this thing would happen? Because a node can't have ever uh, out degree of 2. Am I clear? Okay, great. So that was it for today. If you're watching this stream in the recorded version, feel free to like and comment on this video so that this work could be justified. That's it for today. Thank you and have a nice day.